Reducing a radical. Whenever we reduce a radical, what we're looking for is a perfect square part and a non-perfect square part. We're going to assume that A is a perfect square. And if A is a perfect square, I can use my property of radicals that allows me to split this into two separate radicals. And then if A is a perfect square, we can take the square root of A. Exactly. An example of this. And let's go ahead and list some perfect squares to the side. Excellent technique to do. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. These are all of your perfect squares from 1 through 100. Now, if I take the square root of something like, let's see, 40. What I will do is recognize that 40 itself is not a perfect square. It's not on my list. I will look at my list and I will start my list with the biggest number that's smaller than 40. In this case, the biggest number smaller than 40 is 36. And then I simply say, does 36 go into 40 evenly? Is 36 a factor of 40? No. Next thing I'll ask, is 25 a factor of 40? Is 16 a factor of 40? Is 9 a factor of 40? Is 4 a factor of 40? So since 4 is a factor of 40, I can rewrite this as the square root of 4 times 10. Now, if you look at the line above that, it has it in that correct form where I have a perfect square factor and a non-perfect square factor. I can split my two factors up into the square root of 4 and the square root of 10. With this, I can actually take the square root of the 4, leaving us 2 square root of 10 as the simplified reduced radical form. Now, let's look at another example of reduced radical form. One more example in this format, such as the square root of 75. And again, I'm going to go through my process, basically looking at 64 and below. 64 doesn't go in, 49 doesn't work, 36 doesn't work, but 25 does. So I'll rewrite my 75 as the square root of 25 times 3. Now I can split that into two radicals, one with the 25, one with the 3. Because 25 is a perfect square, I can take its square root. Leaving me 5 times square root of 3 as my final answer. Now, if we pull out a calculator and you plug in the square root of 75 into your calculator, not exactly sure how well this will show up on the screen today. Let's see what we have. That doesn't look too bad. If I take the square root of 75 and hit enter, I get 8.66025,403 as a decimal approximation. If I take 5 times the square root of 3, which is what I said it reduced to, and hit enter, I get the exact same answer. So the form of how we look at the number has changed, but only the form, the value has not. Okay, next thing I'd like to talk about is